Wait, what? No, it's not. Look, she has it right there.
Give me a second. Alright, here we go.
Right, but that's
Yeah, I haven't done anything. Oops, not that. Alright, here we go.
no, that's that. She got ready.
Great.
It's
Alright, so let's do the non-calculus first. When x is 4, f of x is 3 times 4 squared minus 4 times 4 to the 1/2 minus 4. So how about 48 minus 8 minus 4, 36 for our y. So my line, y minus 36, something times x minus 4. Okay. As tempted as you're going to be to grab your calculator when you're doing this, don't. You got to get used, you got to be able to do this without a calculator. So the only way you're going to get better at doing it without the calculator is trying to do it without the calculator. Okay? Even if you make mistakes, if you just grab it, then you're never going to get better at it. 4 to the 1/2, square root of 4 is 2, 2 times 4 is 8, 16 times 3 is 48, 40 minus 4, 36. All right. Calculus part. Derivative function. 6x. Now here's the part tough one. Minus 2x to the negative 1/2. Yeah? No? Everyone okay? 1/2 minus 1 makes a negative 1/2. So when I did my power rule on 4x to the 1/2, my derivative is 4 times 1/2 times x times to the 1/2 minus 1. 1/2 minus 1 is negative 1/2. 4 times 1/2 is 2. All right, now plug in 4. 6 times 4 minus 2 times 4 to the negative 1/2. Four to the negative 1/2. 1 over the square root of 4. Times 2. That's going to clean up to be 1. This is 24. That's 1. So my slope is 23. Yeah, everybody went, yeah, I didn't like that. Okay, so check out it again. 4 to the negative 1/2. When we did this part is 1 over the square root of 4, or it's a half. When I take that times a 2, that turned out to be the 1 right there. Once again, it's so easy when I'm not watching you or you're at home practicing just to be like, oh, I don't feel like thinking about that. Guess what? You're going to have to. 4 to the negative 1/2. You have to be able to evaluate with negative exponents, with fractional exponents, with negative fractional exponents. If it's not something that comes out nicely, then we're going to have an ugly root in our answer. You know, if this had been, and Dennis, I don't know if that was your question, so let me go to your question and then I'll come back. Yes? Wait, say that again. When it's the 4 to the 1/2, 4 to the 1/2 is 2, times 4 is 8, if you're talking about in the original function. 4 to the negative 1/2 is 1 over the square root of 4, or 1/2.
think what he's saying is down here at the bottom it should be 1 over plus or minus square root of 4.
No, it should not be plus or minus square root of 4.
We just use positive. We just assume it's positive.
Yes.
Okay.
Right. I know we keep, and that's, Dennis, is that what you were saying?
Yeah.
Okay. Yeah, I know. When we have a square root, we always are thinking like, oh, I always am going to have a positive and a negative, and that becomes a problem when we're evaluating an expression that has a root in it. When I bring the root in here, and this is why we did this, remember, the reason that this becomes plus or minus isn't because I put a root on a 9, it's because I put a root on an x squared, which gives me the absolute value of x. Yeah, I mean, I know it's, so that's one way to think about it, is like, are you putting the root in versus is it already there? If it's already there, then you shouldn't be, you know, essentially this root is here, it's just a positive square root. Okay, so let's go back for a second, because this is going to be a good, well, not that, because that's another class. And there's where we did power rule. Okay. Remember this page? Here's our revisit to this page. Okay. You were not supposed to do the answer column yet. Absolutely not. You were supposed to look at each of these and, matching it up with the limit definition of the derivative, figure out what function we were looking at and what the a value was. So, for example, if I look at the very first problem, we figured out that was the limit definition 1, that the f of x function that's getting used in here is x squared, because I can see that's what's happening to 4 plus h at an a value of 4. After today's lesson, I can take those 2 pieces of information and generate the limit answer without doing the limit. Because here's what that limit is saying. It's saying, hey, find f prime at 4 when f of x is x squared. Take this function and find the derivative of the function at that number. Well, if f of x is x squared, f prime of x would be 2x, and at x equals 4, that is an 8. And if we ran this limit, if we expanded out this limit and did all the work, we would find out the value of this limit is 8. That's what we're being asked, that's what I'm asking you to do on this. And this is usually how the limit definition of the derivative sneaks its way into the AP exam. They throw a limit at you that looks like, and you think, oh my god, it's going to take me forever to figure it out, if you treat it as a limit. But if you recognize this as a limit definition of the derivative, namely number 2. No, this is still number 1, I'm sorry. It doesn't really matter. It just matters when you look at where the pieces are. What's the function that we're taking the derivative of? Based on the way that limit is written.
X squared.
Not on this, not on that guy.
Oh, on the second one?
On the second one.
2x to the third.
2x to the third. 2x to the third at a equals 5. So what's the value of that limit? because if f of x is 2x cubed, then f prime is 6x squared, and when x is 5, that's 6 times 5 squared, or 150. I want you to finish this chart. If you didn't do the other columns, and you're still having a trouble kind of identifying where we can see things, let me help you with that a little bit. But if you can see what the function is, and you can see what the a value is, then you should be able to use power rule. Now, I will tell you, on a couple of these, you're going to have to think about how to make it a power rule problem. Like 2 over x is not really a power rule, but how about 2x to the negative 1? Okay. That's how 2 over x becomes a power rule problem. We're actually going to talk about that and some other rules involving products and quotients. The product rule and the quotient rule. Not very creative. Okay. But running through the functions on this chart, taking the derivative and coming up with the derivative value that will represent the limit value. Good practice for derivatives. If you sit down to do the textbook homework, some of the textbook homework we're not ready for yet. We haven't gotten all the way through lesson 7. That's okay. If you look at it, you want to try some of it, you can. If you want to wait on some of it, that you can. This is a good thing to do in its place, and or go back to the lesson 6 homework. Okay? One more reminder, if you haven't joined our AP classroom, please make sure you do that. You're going to need to have that set up for all the other AP things we're going to do. All right.